We're asked to find a counterexample to disprove the statement that if is greater than b, then a squared is greater than b squared. Now, of course, this is often true. So 4 is greater than 3 and 16 is greater than 9, but it's not always true. We need to find a situation where it's not true. So let's look at 2 is greater than minus 3. It's all about including a negative here, because when you square a negative, it becomes positive. But 2 squared is less than minus 3 squared. So essentially, as long as you pick any, not actually any, sorry, you have to pick a positive on the left-hand side and a negative on the right-hand side, where the negative has a larger magnitude, then that will be a counterexample. So lots of possibilities. So that's all I really need to write. That's our counterexample. So in B, a student writes this statement. They're saying that sine x equals 0.5 implies x equals 30. There's a little arrow going to the right. And also x equals 30 implies sine x equals 0.5. And we have to explain why it's incorrect. Well, actually, it's okay to go this way. If x is 30, then sine x is 0.5. But the other way is not. It's not strictly true, because if sine x is 0.5, then it implies that x is equal to 30, but some other things as well. Because here's the graph of sine x, there's 30, but another solution is 150, 180 minus 30. You could also add on 360 to get 390. So not just 30. Therefore, to correct the statement, we just have to get rid of the bit going to the right. We can still have the amplification of the right to the left. Okay, there we go. Right, finally in C, it says prove the sum of 4 consecutive multiples of 4 is always a multiple of 8. So let's start out by just writing a multiple of 4, 4n. And the next one is going to be 4n plus 1, which is in a bracket. That's 4n plus 4. And n plus 2, and n plus 3. Could go with n minus 1. That might make life a little bit easier, but I don't know. Here I just felt like going with it like this. Multiply it out. So we get 16n plus 24. And now factorize out the 8. So it's 8 times 2n plus 3. Which is a multiple of 8. And the answers, they did specify that 2n plus 3 is an integer. They gave you the benefit of the doubt if you didn't say this. I kind of felt when I did it, it was just obvious. I didn't even say that n was an integer. It's just sort of anyone like looking at this, seeing that we've defined 4n as a multiple of 4, it's implied that n is an integer, and therefore 2n plus 3 is also 1. But I'm just going to write it here to be, comprehensive. Because if it wasn't an integer, then it might not be a multiple of 8. All right, there we go.